All right, so today again we are talking to Russ. Russ is a software engineer at CodingTech. Hello, Russ.
Hey, good to be here.
Yeah, good to have you back. So last time we talked about all of the data structures. So today maybe let's talk about the code a bit part.
Right. So just to kind of recap, what we talked about last week was Eden is the data file format that Clojure uses, and it's used both for data, but it's also the basic syntax of Clojure code. So last week we spent a lot of time talking about, well, what's it look like just as data? But as you say, this week we're talking about, well, what's it look like as code? I think my first impression of Clojure code was that it looked a little odd. Is that when you first came to Clojure, was that your impression that the syntax was just kind of odd?
Yes, it was. Actually, when I came first to Clojure, there was a lot of odd things. Actually, when I first saw like a Clojure logo itself, I actually folded it like a peace sign, And so there was really a lot of odd things for me. And, of course, the S expressions where you have the parentheses around everything. But I think the more time you spend with this, the more you realize that it's actually, it helped me to think in S expressions. So in those blocks than in, curly braces and different brackets or stuff like that. So that was my first initial thought about Clojure.
Yeah, so I think the thing that gets most people when they first come to a language like Clojure, to a Lisp, is that the parentheses for function calls seem to be in the wrong place. That instead of it being like name of the function, open parentheses, arguments, close parentheses, it's open parentheses, name of the function, arguments, close parentheses. And there's actually, as we talked about last time, there's a reason behind that. And the reason really just is that open parentheses stuff, close parentheses, is a list in the Clojure format in Eden. And since we're using the same format for the data as for the code, we just, the rule is that a list is unless you tell it something else, a list is a function call. So you have an open parentheses to start the list, and you have a close parentheses to end the list. And I think I said this last time, but I think it's worth saying again. There's great things about Clojure, and you really should not just let sort of an odd syntax be the thing that, oh no, I can't use this language because the syntax looks a little odd. If you like the language, if you get use out of Clojure, the syntax will take care of itself, because that's what we do for a living. We're programmers, right? We manipulate odd syntax. Is syntax
Exactly.
Yeah.
I mean, this totally makes sense. And I think there was one more thing that put me off when I looked at Clojure. So apart from parents, there was a prefix notation. And
Right.
Initially, I also thought about this as like, well, why the plus is in the front? But later on, when I learned, well, it's just a function.
Right.
It made my life easier.
Yeah, it's so this is like if you're adding two numbers together, and instead of saying A plus B, right, in Clojure you say open parentheses plus sign A and B, right,
Right,
close to parentheses, and it's a prefix notation. And that does look a little odd, but the thing is that it means that everything you're doing always looks the same in Clojure. And there are times where you're sort of like, oh, it feels a little weird that I'm doing this, but at least you have the comfort of knowing that everything works one way, not 5 different ways, one way. It's always sort of the thing I'm doing first, followed by the arguments.
Right.
And that has some utility just beyond being simple. It actually smooths out a lot of the sort of the mental work that you have to do as you're programming, because there's only one way to do things. I guess one of the most common things that you do in a programming language is you associate a name with a value. In Clojure terminology, we say that we bind a value to a name. So, X is 1, or A is 73, or PI is 3.14159, that kind of thing.
Right. So this would be like a variable in any other language.
In any other language, it would be a variable. In Clojure, well, Clojure has these things called vars, which are not quite variables. And in fact, I wish they had picked another name for var, anything else, because the first thing that sort of hits you as a beginner with Clojure is that the Clojure things that seem to be variables are not really the same thing as variables, and yet they have this name that reminds me of variables. It's
right.
I put that right up there with persistent as a unfortunate choice of terminology, but it's sort of traditional in the Lisp world to call these things vars, I think. So the way you associate a name with a value, or one of the two major ways that you associate a name with a value in Clojure, is you say def. So it would be open parentheses def, because everything's done the same way in Clojure. Open parentheses def, and then your symbol, which might be pi or a or total or whatever, and then some value. So maybe def pi 3.14159, close the parentheses. And that will associate the value, we would say in Clojure, it binds the value 3.14159 to the symbol pi.
Then how is this different to a regular var?
Maybe a better question is, how is it the same? Or maybe the first question is, how is it the same? It's the same in that if after I do that, I say pi, I get the value of pi. So, whatever, if I say def x equals 33, from then on, whenever I say x, I'm really talking about this value 33. So that's how it's the same. Your question is, how is it different? The difference is that vars, despite the name, you really don't want to vary them. They're more like constants in a more typical programming language. So, I say pi is 3.14159, and really I should leave it alone and just let it be. So these var things in Clojure are not really for, like, it would be a really bad idea to use them as a loop counter, the classic sort of in a programming language, I equals 1 to 100 or something like that. They're really more like constants. Having said that, you can actually change the value of a var. So they're not constant in the programming sense that I'm not allowed to change the value. You are allowed to change the value. You just kind of are not supposed to. And why would you do that?
Yeah, why would you do that? Like, everything in Clojure is immutable. So why would you allow to change the value?
Because so you can change the value of a var, because if the language did not let you change the value of a var, it would drive us developers crazy. Because much of what you do, if you think about what programming is particularly interactive programming, the style of programming that you do in Clojure, you're sort of sitting there interactively building your program, right? And maybe I set x to some value, and then 5 minutes later, I think, oh no, I was wrong. As a developer, I made this mistake. X doesn't want to be 3, X wants to be 5. It would be a pain in the neck if I had to restart everything just to fix that mistake.
Yeah, and I think this would be also very often used in the REPL.
Yes.
So in the read, eval, print loop.
Right.
That Clojure developers actually very often talk about.
Right. So what is the REPL? Tell me about how you develop code in Clojure, because I think it's a little different than in a lot of programming. If I'm a Java programmer, I'm either using some IDE, or maybe I'm doing it at the command line. And if I'm doing it at the command line, I edit my code and I compile the code and I run the program and I see there's a mistake and I go back and I do it over and over. But Clojure's not really like that, is it?
No, isn't it? It is not. And actually, when I do this in JavaScript, REPL in quotes is my console,
right,
where I can put some expression, and my actually browser is my console, because when I hit save on my editor, everything is reevaluated and I can see the changes on the website. So this is, I think, a bit different. But I think when you do the server side of things. And when you reevaluate the code from your editor, you can exactly see what kind of values the code evaluates to. Right?
Yeah, it's the kind of utility that you get out of having an IDE. One of the beauties of an IDE is you write the code sort of incrementally, and depending on the IDE, more or less you get feedback very quickly. Certainly there are IDEs for Clojure, but the sort of Clojure equivalent of the compiler comes with this interactive program where you can type in code and see the results right there. So it's kind of baked in at a really low level. Having said that, I think it's important to realize that Clojure is a compiled language. I think we should say that 3 times together. Clojure is a compiled language. And so as I'm typing in code to the REPL, what Clojure is doing is effectively the same thing an IDE would do with Java. It's compiling it into a little bit of, JVM bytecode, I guess, and then running that little bit of JVM bytecode and showing me the feedback. So Clojure is a compiled language. It's worth repeating that.
So in the REPL, we would, of course, define any kind of, we would define our vars, right? So we would define them as you say, like we would define a pi 3.14, but there will be also other things that we can create as our vars, right? It will be not only values, or it will be not only, values would be the wrong word in the Clojure context. It will be not constants. It would be also functions.
Right. So in Clojure, if I want to set like a high level constant like pi, I would say def, really open parentheses def pi and 3.14 or whatever, close parentheses. Remember, everything in Clojure, all of the like operations pretty much look alike. So it's always sort of open parentheses, the verb, and then the arguments, and then close parentheses. So if I want to add 2 numbers together, I say open parentheses plus sign and some numbers and close the parentheses. If I want to bind a symbol like pi to some number, I say open parentheses def, the symbol blah, blah, blah. In exactly the same spirit, if you want to create a new function, typically what you do is you use something called defn, D-E-F-N. So it's open parentheses, defn. You give the function a name, maybe greeting. You give it some arguments, and then you give it the body, which is the code that this function is going to evaluate when it gets called. So the function call the function definition looks just like anything else in Clojure. It looks syntactically like addition. It looks syntactically like associating a name with a value, like a more ordinary name with a more ordinary value. So again, that makes for a fairly uniform code, but the uniformity goes a little bit deeper than that, because in Clojure, a function like this thing, if I call it with 2 arguments, we'll add those 2 arguments together or something, exists outside of something with a name. So you can have anonymous functions in Clojure. And the reason defn is called defn is it's just like def in that it associates a name with a value, only the value that it's associating with the name is not like 37 or some string or something like that. It's a function value. It's basically some code that takes an argument that does something. And so when I say defn, I don't know, hello world, I'm associating this function, some code that maybe takes some arguments with a name. And it's actually the same mechanism that associates, 3.14 with pi, associates this function value with the name that you give it.
Right. And then we would, so just taking up the example, so we talk about the function greeting. So we would open the parent dfn greeting, and then we would provide the arguments in a vector data structure, right?
Right. So recall from last week that a vector is really just, syntactically, a vector is just square brackets with some stuff in the middle. And I think The reason the arguments are in a vector in a function definition is just to make them look a little different from everything else. So you've got open round parentheses, def n, the name of the function, and then an open square parentheses, which, yes, is a vector, but really I think it's just sort of there to make the arguments stand out a little bit more.
Yeah, and I think it's actually a very good choice by the language creator that actually he uses this different data structures to, I think when you look sometimes at Lisp code, I think the parents, they're rounded ones.
Mm-hmm.
I think sometimes they might be maybe a bit too much of them.
Right. Yeah.
But I think in Clojure, I really love this part of syntax where you can really see, okay, this is my argument name, this is in vector, and then, you have all of those things separated. Since Clojure is a functional language, meaning the functions are very strong in Clojure. So we can do much more with the arguments, and we can have something called variadic functions.
There's a great word, when I was a kid, we would call that a $20 word, a really, really big word, which just means you can write a single function which takes different numbers of arguments. It's a really very simple, pedestrian, easy to understand idea with a great big scary name on it. But so yeah, you can actually with an extra set of parentheses, because this is a Lisp, and so there is no problem that we can't solve with an extra set of parentheses or two. You can actually define a single function, say it's called greeting, and maybe that function takes one version of that function takes no arguments and just sort of says hello out there or something. Or it might take one argument, in which case it'll say maybe the argument is name, in which case it'll say hello and name. Or maybe it takes 2 arguments or 4 arguments or 8 arguments. Many programming languages have this feature where you can define a single function that has multiple numbers of arguments in it. And that's really all variadic functions are. And it literally is just a case of syntactically of adding an extra set of parentheses here and there.
Right. So throwing again another word at you, which is multi-arity functions.
Multi-arity. Let's see. Is that the one? I actually get these confused. So multi-arity is
the one with ampersand.
Is that?
Yeah, that would be the one with ampersand.
Okay. I thought maybe what I just described was multi-arity, and the other one is variadic. It doesn't matter. The other thing that you can do is you can do the everything else argument, right? You can say, okay, here's a function, and it takes 2 arguments, just for example, plus whatever, in which case you can call this function with 2 arguments or 3 arguments or 4 arguments or 5 arguments, and everything past the first 2 get sort of put in a like a list-like data structure that's then passed in. So frequently programming languages will use sort of a star to indicate this, or ... or something like that. Clojure uses an ampersand followed by the sort of catch-all argument.
Right. Yeah. So just to clarify, so with the ampersand, it will be multi-array functions. Okay. And then the functions with different implementations for the number of arguments will be the variadic functions.
Okay, if you say so.
All right. Yes. Yes. Well, you're the master here. I just looked it up.
I honestly, I do think that these are like words that we borrow from language designers, but I think there's very few programmers who would have trouble with, there's a couple of different ways that you can have various numbers of arguments passed into the same function, and we just talked about both of them. So
exactly, yeah. And then and just following along. I mean, in the book that you wrote, so the book is called Getting Clojure, and it's by Pragmatic Press. I'm correcting myself this time. You also put multi-methods in the functions, and I think this was one of the moments when I read the book. It was like, so it's actually belonging here and not to the polymorphism, which I always felt like was a bit of place. So what are multi-methods?
So multi-methods are a completely general purpose way of doing polymorphism. And I've just been making fun of big words, but here I am.
Here we go.
So polymorphism, if you're familiar with if you're an object-oriented programmer, you tend to think, I thought this for a long time, that polymorphism was sort of a property and a talent of object-oriented programming languages. It turns out it's you see it a lot in object-oriented programming languages, but it's really something you can have outside of object-orientedness. But in an object-oriented programming language, right, polymorphism is this idea that I call a method on some object, and the actual method that gets executed depends on the type of the object that I'm calling, so that, I don't know, I add two integers together and that's one bit of code, or I add two floating point numbers together and that's a different bit of code, or I add two strings together and it all, maybe it's the same method, maybe it's .add, but it does different things depending on the actual type of the object that I'm calling it on. That's kind of the idea of polymorphism in an object-oriented language. More generally, polymorphism is I do an operation and the specifics of how that operation gets done depend on the arguments that I'm passing into the operation, where in the object-oriented sense, you can sort of think of the object that you're doing it on as sort of the first argument. So what's a multi-method? A multi-method in Clojure is basically a function, but it's a function that's kind of broken up in the pieces. There's one part of the function which looks at all the arguments and categorizes the arguments. So if you were writing that add things up operation as a multi-method, maybe it has two arguments, and you would look at the two arguments and you would say, these are both strings, so I should categorize this as adding two strings together. Or, these are both integers, I should categorize this as adding two integers together.
Right.
The second part of it are the actual bodies that deal with the different cases. So if I classify these arguments as, these are the kind of arguments that add two, these are both strings, so I'm adding two strings together, then I supply a method body, kind of a body of the function, which knows how to deal with that case. So in a sense, multi-methods are like a really elegant way of writing that function or that method, that code that we've all written, where it's a giant case statement where I'm saying, what do I have here? Do I have one of these and one of these, in which case I'll do that? Do I have one of these and one of these, in which case I'll do that? It's a way of looking at the arguments and deciding what's in these arguments, and based on that decision, how do I handle, which version of this function do I use?
Right. So just maybe summing this up. So the variadic function works on the number of arguments you provide to the function.
Right.
So if you have a lot of them, there will be a different implementation. If you have 2, 3, 4, what have you. And then the multi-method will be based on the type that you pass to the argument.
Actually, no, it can, but it's more general than that. Okay, because the categorizing that goes on with multi-methods can be any characteristic that you compute from the arguments. So how can I put this? So just go back to the idea of a multi-method that maybe is adding things together. You can look at the arguments, and it's not just the type of the arguments. You could look at the arguments and say, that one's negative and that one's positive. So I'm going to categorize this as adding a positive and a negative number together, right? Where positive and negative numbers, they're the same types. I can, this is a better example is I'm doing something with a bank account, and I look at the bank account, and it's all a bank account, and I say, is this bank account overdrawn? In which case I'm going to use this version of the function. If the bank account is not overdrawn, maybe I'm going to use this version of the function. And maybe if the bank account has $2 million in it, I'll use a third version of the function. It's any characteristic that you can pull out of the arguments, that you can compute from the arguments, you can essentially polymorph on using multi-methods.
All right. So if you're listening to this and you still don't know what we're talking about, I would again recommend getting the examples from the Russ book, because there is an example with the book titles. And then exactly, I think when I read through this, I was like, okay, now I got it, So that was very nice. And then there is one more thing with the functions that we can do, which is the pre and post condition. So
yes, and those are, I almost don't have to say anything else, right? Functions have pre and post conditions. They're essentially assertions on the arguments coming into the function and assertions on the result coming out of the function. Right.
Right. And when you do the pre and post, what's the mechanism? What is, like, if the function doesn't pass sort of the precondition, what happens?
If memory serves, and it's been a while since I've done pre and post conditions, doesn't it throw an exception?
I was thinking about it would be such a good actually tool if you could do a dispatch function on the pre and post. Because I think it would have a lot of value checking the input fields, for example, from web, but it only throws the exception, so you cannot really trigger anything out of this,
Well, you could, you could write a multi-method to handle that.
Yeah, but in this case, just a when will do.
Yeah, that's true too. I find I know a lot of my colleagues use pre and post conditions a lot. I tend to use when or if or things like that. I think that's a stylistic thing. I certainly don't have any objection to pre and post conditions on functions. I just tend not to use them.
Right.
So,
all right.
Yeah.
So we define our function.
Right.
And we have our body of our function. And inside our function, of course, we can define our symbols, right? And then we can rule.
Well, so here's the thing. We've talked about how you can bind values to symbols with def. But really, def is for symbols that are relatively constant and relatively high level. Okay, so you would, if I really did have the constant pi, I was dealing with circles or trigonometry or something, I would probably put that at a relatively high level inside, right, directly in a namespace, which we'll talk about in a little bit, I think. But there's another sort of name value binding that you want to do sort of inside your functions or inside your multi-methods, which is, this is just a local variable, if you will, local symbol. I don't really want it to be global. I don't want it to leak out of this function. I just want to, I'm in the middle of computing something and I don't want it, it's just local to this little bit of code, probably a function. And for that, you use something, a different closure construct called let. And let is essentially, well, it's sort of like the name says. You say let, you give it a name and a value, or perhaps several sets of names and values, let title equal some string, let I equal 4, let, any name equal any value. And then given that name is bound to that value, evaluate this expression. And the difference between let and def is that when you def something, it stays around, right? I say def pi equals 34. Later on, it doesn't matter where I am in the code, that var is still set to, well, 34 would be a terrible value for pi, but 3.14. Where let, it's what's the technical term for it? It's lexically scoped. The let is only around in sort of the actual text of
inside the body of the function.
Inside the body of the let, really, is the
all right. Yes, yes, correct.
And under the hood, behind the scenes, let and def really work very differently. Def actually. There is a symbol, essentially a name to value table that actually exists in the closure runtime. It's called the namespace. I think we'll talk about these in a second. And when you say def or you say defen, What you're actually doing is putting an actual physical entry in this table that says this name is bound to this value. And those tables, these namespaces, they hang around until you do something to get rid of them. So when you def something, you are actually creating a thing that binds this name to this value. Let is completely different. Let is more like a compiler thing. It's closer to the variables that you have in a more mundane programming language, a more standard programming language. And so there's nothing like in the runtime that you can point at that says, oh, this is the place that's binding my name to my value with let. It's more like, hey, compiler, assign this name to this value, and maybe you'll put it in the register, or maybe you'll push it on the stack. I don't know. I don't care. I just want, when I say X, I want that value. So let is much more sort of hidden and behind the scenes as it's implemented, where def is very definitely you are creating a thing.
Right. So with let, then we would use the let bindings like any other variables in any other programming languages?
Right. Well, more or less. The thing is that you cannot really. So again, everything is immutable in Clojure, and Clojure kind of just strongly discourages this sort of computing by mutability thing. The classic one being, I equals 1 to 100. You tend not to do that in Clojure, and so let you can.
Would it be fair to say that let is used when we just want to maybe simplify our functions and then create some kind of bindings for some more complicated code that comes to the function?
I think that's probably a good way of putting it. So if I have some huge expression, which is, I'm gonna have this thing, which is some huge expression, and I'm gonna add it to this thing, which is some huge expression, and I'm gonna add it to this third thing, which is some huge expression. I might let the first thing, the second thing, and the third thing, and then add up those three symbols. And effectively, it's the same thing. And in fact, the compiler might generate the same code in either case, but by using the let, you're sort of making things a little clearer in your code.
Right. So we went all the way down to the function bodies and the let. Let's just go totally opposite direction and talk about namespaces.
Okay. Namespaces are, well, there's a couple of ways you can look at them. One is, what are they physically? And really, namespaces are essentially a map between a name and a value, or a set of, this name with this value, this name with this value. So the kind of the obvious model for a namespace is that it's a hash table, a map, whatever, that sort of name value kind of thing. That's what a namespace is, essentially, except that every namespace also has its own name. Okay, so for example, Clojure comes with a rich set of library functions that let you do all kinds of amazing things, including do all this stuff with sequences that we talked about last time.
Right.
Almost all of those functions live in a namespace called Clojure.core. So Clojure.core, that's the name of the namespace. And then inside of that namespace are a whole bunch of name value entries. And for Clojure.core specifically, most of those entries are functions that do wonderful things. So for instance, first, which is the function that will give you the first item on your sequence. Well, if you looked in the Clojure.core namespace, you would find a symbol, FIRST, and its value would be this function that knew how to give you the first thing from your sequence. And there's, I want to say there's a million. There's not a million. There's probably a couple of hundred things. That's one namespace. Another namespace that you come across quite frequently in Clojure is user.
Yeah.
Well, user is just kind of, it's like the Scratchpad namespace. When you first start out Clojure, there's also this idea of the current namespace. What namespace am I working in right now? If I do a def, if I say def x equals 64, what namespace does that X and that 64 go into? It goes into the current namespace. There's always a namespace that's kind of the one I'm working on right now. It's if you're a programmer and you're sitting there coding in the REPL, it's the namespace that you're adding things to. And user is sort of the default one. It tends not to get used in real programs very much, but if you just start up Clojure, Clojure will create kind of an empty namespace for you, call it user, and make it the current namespace so that you always have a namespace that sort of mess around with and create functions. And if you're a beginner, it's the namespace you tend to learn Clojure in.
Right. So it's like when you open a Word document and you have first a blank page.
Exactly. It's precisely that.
How could we compare namespaces to any other languages? Like in object-oriented programming, what would be the equivalent of namespace if there could be one?
So I think in C++, the equivalent, I think it's been ages since I've done C++, but I believe the equivalent is called a namespace. In Java, I think the equivalent is a package, but they're not.
Okay.
And packages and namespaces, they're not exactly the same. I won't sort of talk to packages because it's been a while since I've done Java. But again, a namespace in Clojure is an actual runtime thing. So somewhere Clojure has a list of namespaces and the names of those namespaces. And then if you sort of look up on, a particular namespace user, there is actually in Clojure some memory devoted to this name value table, which has the name user, or this another name value table, which has the name Clojure core with 700 whatever entries in it.
Right.
And there's actually an API in Clojure. It doesn't get used an awful lot, but there's actually an API in Clojure where you can manipulate namespaces. You can say, for this namespace, look up this symbol and give me this value. There are things that are out there. My impression of Java is that that's not really true of packages in Java. Packages are a little more like built into the language and a little less of like something you manipulate. I could be wrong about that, but psychologically in the programmer's mind, I think namespaces in Clojure are pretty much the same thing as packages in Java. They're sort of the same thing as, I think, modules in Python.
So would it be fair to say that actually namespaces are places for us that we can organize our code for a specific, domain of our development?
Well, we could say that only if you wanted to be a lot more articulate than I just was about it. But yes, I think that's exactly right. It's the place where you kind of organize all your stuff.
So just as let allows us to maybe organize something inside a function, the namespace would be the place where we organize our function.
Yeah, so I tend to think of it, I think this is what you're getting at. I tend to think of it as sort of there's kind of three levels of code. There's the very small level where you might have let and things like that, and I'm kind of going expression by expression. I'm really down in the details. Then there's kind of the functional level where I'm writing functions and I'm pulling my functions together to do bigger and bigger things. And then there's the namespace level where maybe a really significant program might be made up of 20 or 30 namespaces, where a smaller program might just be a handful or one.
Yeah, so I think we also talked about multi-methods, that they are part of sort of polymorphism. And there are two more things in Clojure that I have to say I didn't use that much. And one of them is records and the other ones are protocols.
Okay, records and protocols.
So what are records?
Okay, a record is as close as Clojure comes to doing object-oriented programming. Okay, a record is a bundle of names and values, right? So it has that sort of object feel of it has fields in it.
Like a map.
Like a map, right? But a record, unlike a map, where if you recall, map is in Clojure, it's just kind of like a hash table or something. I can put names and values in it, and I can make up the names on the fly and put the values in. A record is a more stately and organized version of that. So typically with a record, you say, here is my record type, and here are the fields that will go in this record. So I might have a record called employee, and the fields might be employee number and first name and last name and that kind of thing. Records differ from what you typically find in object-oriented languages in that records, like everything else in Clojure, are, what am I going to say, immutable. So you cannot change the data in a record in place.
So when I would be defining a record, I will open my parents, and then I will do a def record, and then I would provide keys or key values.
You would provide just the keys. It's def record and the name of the record, and then a vector of the fields in the record.
And what would be the advantage of doing this over just having a map?
So there's a kind of a technical advantage, and then there's, how do I want to say it, like a code clarity kind of advantage. Okay. The technical advantage is, since you're declaring these fields up front, Clojure can generate faster data access to those fields than it could if you just had an arbitrary map. Okay. So if you have 1 trillion records and they have lots of fields and there's data, you're creating these records and then pulling the data out of the records, quite often, very intensely. The records have performance advantage that you might want to take advantage of. I'm not sure I've ever written any code where the performance advantage of records would make any difference. But the other advantage of records is that they have a clarity in the code, right? Instead of just making a map, I make a record, and the record has a particular type: employee, department, I don't know, aircraft or something, and that helps make the code clear. And then the fields in the records, again, it makes the code a bit clearer. Having said that, there are reams and reams and reams of perfectly good Clojure code that just ignore records. There's lots of Clojure code that uses them. They're not, and the reason I point that out is that records, while they are, I'm sort of assuming that most people coming to Clojure, they're coming from an object-oriented background, and records feel all too comfortable to people who are coming from an object-oriented background. And I went through this too when I got to Clojure, and you sort of think, oh, well, here are my classes, and I should put everything into a record, and I should express all of the major concepts in my code as records. And yeah, sure, you can do that, but you don't have to. And there's a lot, as I say, there's lots of Clojure code that use no records or just use very few of them. And in fact, I recently did an analysis of Pedestal, which is a pretty large chunk of production Clojure code. It's actually the code it's a library for providing the plumbing for applications in Clojure, so that, that library where it's like, oh, I've got a request in and I need to parse the parameters and maybe route it to the right place. Pedestal does that sort of stuff. And Pedestal is a lot of Clojure code. And unfortunately, I don't have the numbers in front of me, but I think, there's hundreds and hundreds of functions in Pedestal. And I think there is maybe 15 record types. So if you think of, a huge chunk of code, and it's got 15 record types, and that's probably the right number for Pedestal. Records are handy, but they're not the central feature of Clojure that you might think they are if you have an object-oriented point of view.
So record would be like a blueprint for predefined fields that I would like to sort of have in my map. Would that make sense?
Yes.
Okay. And what if I want to put any kind of, in object-oriented, there will be methods on my record. Would I do this using records?
So if you want to do sort of that object-oriented kind of polymorphism that we know and love from the object-oriented world, what you need to do is you need to mix in some protocols with your records. So what's a protocol? A protocol is a bundle of function signatures. Okay, so if you think of, and the closest analogy I think is a Java interface, right? A Java interface sort of says, hey, I'm an interface and I define these methods, and any object that claims to support this interface has to implement these methods. Well, a protocol is a bunch of functions, and basically the contract with the protocol is that any record that claims to support this protocol should implement these functions. So what you can do is you can define one or more protocols, which again are just function signatures, bundles of function signatures, and then you can define record types, and those record types can say, and I implement this protocol, and when I see this function from the protocol, do this. And when I see that function from the protocol, do that. And so you basically kind of define how this function from this protocol is implemented on this record type. That is a long sentence.
Right. But so this is this sometimes when you read about Clojure, look at it, this is called this a la carte polymorphism.
Yes. So between, I think, multi-methods and records and protocols, you have polymorphism that can work in a number of different ways. And the thing with Clojure is the polymorphism isn't necessarily married to objects or object types and things like that. Again, it's sort of like I think from a Clojure point of view, the typical object-oriented language is too tangled up in itself. There's too many features that just come along for free, except that they're not free. That if nothing else, they sort of complicate the programming model. And the Clojure idea is the key is that a lot of those features are great. And, things like polymorphism and having, sort of object-like things that have definite fields, that's great. You don't need them all the time. And when you need them, you want to use them in just the combinations that you want to use them in.
Right. So just summarizing this. So in Clojure, we have now, is this 3 kind of polymorphism? We would have multi-methods, we would have records and protocols.
I sort of think of it, I could be wrong here, but I think of it as 2 different kinds of polymorphism. I think of it as multi-methods are completely general. You can throw any set of arguments at a multi-method that you can build a multi-method that can handle any set of arguments and do anything it wants with it. And that's completely general polymorphism. The records and protocols give you type-based polymorphism. I have one record type and it implements a protocol and it does it this way. And I have a different record type and it implements the same protocol, but it does things differently. And so it's based on the type, like the record style polymorphism is based on the familiar type-based polymorphism, which you find in most object-oriented languages. The multi-method style of polymorphism is based on whatever you can cook up. So it's a very general purpose one that you can do anything in the world with. And then it's a type-based one, which works more like the familiar object-oriented kind of way of doing things.
Yeah, I think this was very good, Russ.
Thank you.
I think we can there's a couple more things that we will discuss, but maybe not today. So thank you so much for today.
Well, thank you. It's been my pleasure.
And then we kick it up next time.
Bye.
Thanks. If you find this podcast valuable, there are many ways you can support it. You can review it on iTunes or any other platform you're listening to. You can share it on social media with your friends. You can blog about it, discuss it on your own podcast, and you can support it directly by buying my video courses and learning ClojureScript and Clojure at my website, jacekschae.com. That's jacekschae.com. Thank you for your support of this show.